It begins, as these things often do, not with a sudden explosion, but with a quiet whisper. Imagine the digital pulse of observatories around the world, telescopes scanning the dark, cold emptiness of space. They are looking for the familiar asteroids that might pose a threat, distant supernovae, the routine movement of planets. And then one telescope, the Atlas Asteroid Terrestrial Impact Last Alert System in Hawaii, flags something. It's just a dot, a faint, blurry point of light moving against the fixed tapestry of distant stars. At first it is just another entry in a catalogue, another comet candidate. The automated systems track it, and astronomers begin to calculate its path, its orbit. They feed the data points, where it is, where it was, how fast it's moving, into their computers. And then the whisper becomes a shout. The computers spit out a result that doesn't make sense. The numbers are wrong, the orbit is impossible. It isn't a gentle closed ellipse, the familiar looping path of an object bound to our sun. This path is wild. It's an open curve, a mathematical scream telling us this object is not on a leash. It is not one of ours. The news alerts begin to ripple outward. First in specialized astronomical bulletins, then in science journals, and finally bursting into the mainstream consciousness. A new visitor has arrived. They give it a formal name, a cold scientific designation 3I Atlas. This name is everything. It is a label that separates this faint dot from nearly every other object humanity has ever witnessed. Let's break it down not as a symbol, but as a theory. The Atlas part is easy. It tells us which telescope found it. The I is the revolution. It stands for interstellar, and the 3, that perhaps is the most stunning part. It means this is only the third object in all of human history that we have confirmed has come from the dark silent abyss between the stars. We are not alone in the way we often think. We are surrounded. Our solar system is a busy, crowded and messy place. To understand why 3I Atlas is so profound, you must first understand our own backyard. We live in a nested kingdom. We have the rocky inner planets. Beyond them, the gas giants. Beyond them, starting near the orbit of Neptune, lies a vast, scattered junkyard of icy bodies. This is the Kuiper Belt. It is a freezing, dark ring of cosmic debris, the leftovers from the formation of our solar system. When a comet from this region gets nudged by gravity, it might fall inward toward the Sun, becoming a short-period comet like the famous Halley's Comet, which visits us on a reliable schedule. They are part of the family, but our territory doesn't end there. Go further, go much further. Imagine stepping so far back that our entire solar system out to the orbit of Pluto becomes a tiny bright speck. You are now in the realm of the Oort cloud. This isn't a belt. It is a theoretical ghostly sphere that surrounds us, a bubble of perhaps trillions of frozen objects marking the absolute final gravitational boundary of our sun's influence. It is the deep dark frozen attic of our solar system, extending almost a light year in every direction. Comets from this far away are long-period comets. They might take 200,000 years to loop around the Sun once. But here is the key: every single object in the Kuiper Belt and every icy body in the Oort cloud is ours. They were born here. They were forged from the exact same spinning cloud of gas and dust that created the Earth, that formed the iron in your blood and the calcium in your bones. They are our distant frozen siblings. When we study them, we are studying our own history. They are family. 3I Atlas is not family. Its speed is too high. Its trajectory is too steep. The math is undeniable. This object did not come from the Kuiper Belt. It did not come from the Oort cloud. It came from somewhere else. It was born in a different solar system. It was formed in the dusty swirling disk of a star that is not our sun. A star that may be hundreds or thousands of light years away. A star that we see as just another anonymous point of light in our night sky, or perhaps one that is too faint to see at all. This small icy wanderer was likely ejected from its home system billions of years ago. It has been drifting, tumbling silently through the ocean of the galaxy, a true ghost for an amount of time that strains human comprehension. It has sailed through cosmic nurseries, past the glowing remnants of dead stars, through unimaginable cold and darkness. It is a piece of another world, a message in a bottle thrown from a shore we have never seen. And now this ancient traveller, this silent witness to the galaxy, is passing through our neighbourhood. It is cutting through the plane of our solar system, an alien interloper on a cosmic tour. And as this news breaks, we find its location, we track its path. This is where the scene becomes truly historic. The visitor is not just in our solar system. It is at this very moment flying past the orbit of a planet we know very well. It is flying past Mars. Think of this. Mars, the red planet. The focus of our science fiction, our rovers, our dreams of expansion. We have mapped its valleys. We have tasted its soil with our robotic laboratories. We know its dust storms, its thin atmosphere, its polar ice caps. Mars is familiar. It is the next door defined. And right now, this piece of another star's legacy, is sailing silently past it. Imagine the view from a spacecraft hovering in that cold dark void. In one direction you see the familiar dusty red globe of Mars, and moving against the black star-filled curtain you see a faint fuzzy smear of light. A head of ice and dust perhaps trailing a ghostly tail illuminated by a sun that is not its own. The familiar and the profoundly fundamentally alien crossing paths in the dark. This is the encounter. This is the moment. 3i Atlas is not just a scientific curiosity. It is a whisper from the deep. It is a physical, tangible reminder that our solar system is not an island, but a coastline, and that the ocean of interstellar space is vast, dark, and full of messengers. We are listening, and this is the story of what it told us. We had found it, but finding it and understanding it were two very different things. From Earth 320 million kilometers away, Atlas was little more than a ghost. It was a phantom in our largest telescopes, a blurry smudge of light moving with a purpose that was not its own. It was falling, yes, but it was falling with the memory of another star's gravity, following a path that could only have been carved by an origin story far beyond our own solar family. We could measure its speed, we could calculate its trajectory. We could see it was not from around here. But what was it? A rock? A shard of ice? The core of a shattered ancient planet? From Earth, we were simply too far away to tell. We were like trying to understand a person's life story by looking at a single blurry photograph taken from a mile away. We needed to get closer. And then the universe decided to give us a gift, a moment of pure statistical beautiful luck. It was a miracle of timing, a cosmic coincidence so profound it still sends shivers down my spine. As astronomers and mathematicians on Earth refined the orbital path of this interstellar visitor, a new calculation appeared on their screens. A quiet realization that must have spread through control rooms and universities like an electric shock. Atlas was not just passing through our solar system. It was on a direct course to fly right past the planet Mars. This had never happened before, not once in human history. We had seen interstellar objects before, yes. The strange cigar-shaped Oumuamua tumbled past us too quickly, a ghost detected only as it was already leaving. The comet Borisov gave us a glimpse, but it was still a comet, a familiar icy wanderer. Atlas was different. It was passing close, very close to a planet where humanity already had a foothold. A planet where at that very moment we had eyes. We already had spacecraft there. Think about that. The sheer staggering luck of it. After billions of years of cosmic silence, an object from another star system arrives, and it just so happens to fly within range of the one other planet in the universe where we have active, sophisticated robots in orbit. If it had come 100 years earlier, we would have missed it entirely. If it had chosen a different path past Jupiter or Saturn, our probes there would not have been in the right position. But it chose Mars, and we were waiting. Our eyes on Mars were not built for this. They were never ever designed to look up. Their job was to look down. I want you to picture two of the most incredible machines humanity has ever built. First, there is NASA's Mars Reconnaissance Orbiter, or MRO. For years, this incredible probe has been our chief cartographer of the Red Planet. Its high-resolution camera, a marvel of engineering, was designed to see individual boulders, to trace the paths of ancient dry rivers, to watch dust storms swirl across the Oka Plains. Its entire existence was dedicated to the study of the surface. Then there is the European Space Agency's Mars Express, a veteran, a pioneer that has been orbiting Mars for decades, mapping its minerals, probing its thin atmosphere, and giving us our first three-dimensional views of its majestic canyons. These orbiters are geologists, meteorologists, and surveyors. They are not astronomers. Their lenses, their sensors, their software. Everything was optimized for looking at the bright reflective surface of the planet just a few hundred kilometers below them. And now we were asking them to do the impossible. We were asking these geologists to become astronomers. From mission control centers back on Earth, a frantic, brilliant series of commands began to fly across the solar system. It was a scramble. Could we even do it? Could the software handle a command to point away from the planet? Could the cameras focus on a dim object at infinity? Would the spacecraft's orientation systems designed to stay locked onto Mars even allow it? It was a delicate, dangerous dance. The teams had to reprogram these billion-dollar machines on the fly. They had to ask MRO, our prized photographer, to ignore the planet it knew so well and pivot its entire body. To turn its powerful lens away from the canyons and craters and point it toward the cold, empty blackness of deep space. They were asking these faithful servants built to look down to finally look up. And so the stage was set for the most improbable observation in human history. From Earth, as I said, Atlas was just a blur, a frustrating smudge of light that teased us with its secrets. But from the orbit of Mars, we had a front row seat. We were no longer 100 million kilometers away. We were going to be right there as it passed. This was not a blurry photograph. This was an encounter. Imagine the moment. The final commands are sent. The data packets travelling at the speed of light take 20 minutes to cross the gulf between Earth and Mars. On board the Mars Reconnaissance Orbiter's internal computers process the instructions. Slowly, carefully using its tiny thrusters, the entire bus-sized spacecraft begins to turn. Its solar panels adjust. Its sensors lock not on the familiar red ground but on a set of coordinates in the dark. The spacecraft is now flying sideways through its orbit in a way it was never meant to. Below it, Mars drifts by unseen. Its powerful high-resolution camera, a lens that could spot a beach ball from orbit, opens its shutter. It is not looking for a beach ball, it is looking for a traveller from another star. And it sees it. The first data streams back to Earth. The anticipation is unbearable. Scientists are crowded around screens at the Jet Propulsion Laboratory at ESA at universities around the world. The first images appear. It is not a blurry smudge. It is a shape, it is real. Even with an instrument not designed for it, the proximity is what matters. We can see it. We can see its form. Is it long like Oumuamua? Is it a sphere? Is it a chaotic tumbling cluster of rocks? The camera on MRO, even in this improvised mode, is giving us visual data that is 1,000 times better than anything we could get from Earth. We can see how it rotates. We can see bright spots and dark spots on its surface. We are for the first time not just tracking a point of light, we are observing an object. But the purpose of this moment went far beyond just getting a picture. The real prize was the data we were never meant to get. These orbiters don't just have cameras, they have spectrometers. A spectrometer is an incredible tool. It's a way of seeing the colour of things that are invisible to our eyes. It breaks down light into its component parts, revealing a unique chemical signature. The spectrometer on Mars Express, for example, was built to analyse the minerals on the Martian surface to tell the difference between iron oxide and sulfate-rich rock. Now that same instrument was pointed at Atlas. This was the moment of truth. This was the first time in history we could directly taste the building blocks of another solar system. What is this thing made of? The light from Atlas, after travelling for perhaps millions of years from its home star, now entered the sensor of the Mars orbiter. It was split into a spectrum, a rainbow of data. And in that data we would find the answers. Is it made of the same stuff as our solar system? Do we see the familiar signatures of water ice, of carbon, of silicates, the same materials that built Earth and Mars and us? If so, it would tell us that the ingredients for life are common, that solar systems everywhere are built from the same universal recipe. Or is it different? What if the spectrum showed something else? What if it was rich in minerals we only see in the deep cores of planets? What if it was made of exotic ices or metals that are rare in our own neighbourhood? This data was the first ever sample of alien chemistry delivered right to our doorstep. This was our one shot. Atlas was not stopping. It was not slowing down. It was a fleeting visitor, a bullet from interstellar space. It would scream past Mars and be gone, continuing its long fall toward the sun, before being flung back out into the void, never to return. We had this one narrow window, a few hours where our repurposed, hard-working orbiters could stare at it, measure it, and capture its essence. The purpose was simple: to capture the first ever close-range data of an interstellar visitor. To use tools we had on hand for a job they were never intended for. To seize this one impossible lucky moment. And as the data flowed back, as the gigabytes of priceless information crossed the void and were collected in the deep space network antennas on Earth we all knew, nothing would be the same. The silence of the universe had been broken. We had for the first time truly met a traveller from a distant star, and it had passed by our tiny robotic outpost at Mars, a chance encounter that forever changed our understanding of the galaxy. We were no longer just looking at the stars, we were meeting their messengers. Of all the mysteries we've discussed, all the whispers from the dark, this one might be the most profound. It is the one that moves from theory to fact, from a guess to a measurement. When we look at the stars, we are in a way looking at ghosts. We see the light from things that happened millions of years ago. But when an object from that darkness physically enters our home, our solar system, it is no longer a ghost. It is an envoy. It is a messenger carrying a physical piece of another world, and it is here right now. With Atlas, the message was written in an eerie, ghostly green light. This was by far its most shocking and defining feature. As it drew closer to our sun, this traveller didn't just reflect light, and it didn't just grow a tail of dust, it began to glow. It lit up with an ethereal green aura, a phantom colour that pulsed against the blackness of space. In our human series, a green light is often a sign of magic, of poison, or of something alien. As it turns out, science agrees. That light was not just for show, it was not a decoration, it was a signature. Reading the light. How can a colour tell us so much? It's because in physics, light is a language. We have a remarkable tool called spectroscopy. It sounds complicated, but the idea is simple. You take a beam of light from a star, a planet, or in this case a comet, and you pass it through a special crystal or grating. This prism does what a raindrop does to sunlight. It splits the light into its full rainbow, its spectrum. But when you look closely at that rainbow, you don't just see a smooth blend of colours. You see tiny, sharp, dark lines. And sometimes you see bright, super concentrated lines of one specific colour. These lines are a chemical fingerprint. It's an unbreakable law of the universe. Every single element, every molecule, when it gets heated up, releases energy as light. And it always releases it at the exact same specific colours. Hydrogen has its own set of lines. Helium has a different set. Sodium, the same element in your table salt, burns with a very specific bright yellow. This is how we know what distant stars are made of. We have never touched one, but we can read their light and see the fingerprint of hydrogen, helium and iron. So when Atlas flared with that haunting green light, astronomers did exactly this. They pointed their best telescopes at it, split that green light apart and read its chemical fingerprint. They were looking for the familiar. What they found was the alien, the familiar recipe of our comets. To understand why Atlas's signature was so bizarre, we have to first understand what is normal. Our solar system is full of comets. We know them well. They are our dirty snowballs left over from the birth of our own planets 4.5 billion years ago. They are born in the cold outer regions of our system in the Kuiper Belt or the vast spherical Oort cloud. Our recipe for a comet is well understood. The number one ingredient is water ice, lots and lots of frozen water. Mixed in with that is dust, mostly silicates or fine rock, and some frozen gases like ammonia and methane, and of course some simple carbon-based molecules. When one of our comets falls toward the sun, the recipe comes to life. The sun's warmth heats the comet. The water ice turns directly into gas or sublimates. This vapour erupts from the comet's surface, dragging dust with it, creating the beautiful classic watery tail. Sometimes our comets do glow green. It's a colour we recognise. In our comets, that green light is the fingerprint of a simple molecule called dicarbon, just 2 carbon atoms stuck together. It's a normal byproduct of the sun's light breaking down other molecules. We see it, we nod, and we say, ah yes, a classic comet. That is what we expected to see. We expected a familiar signature. We expected the strong fingerprint of water. Atlas did not have the fingerprint of water, and its green was not the simple dicarbon we were used to. Its recipe was from a completely different kitchen, the alien formula. When astronomers read the light from Atlas, the fingerprints that jumped out were shocking. The normal signals were weak or missing entirely, and in their place, strange signals were boosted to incredible levels. The recipe for this alien traveller was not water-based. First, the dominant ingredient was carbon dioxide. Not water, dry ice, an enormous overwhelming fingerprint for carbon dioxide or CO2. This was the main engine driving its activity. This was the ice that was turning to gas and blowing its tail out. This is a profound clue. To get this much carbon dioxide, the object must have formed in a place that is unimaginably cold. It had to come from a part of its home star system where it was so cold that carbon dioxide itself, which we know as a gas, became the primary ice, the primary rock. This is a place far, far colder than the region where our own comets formed. Second, it was loaded with carbon monoxide. Alongside the carbon dioxide was another ghost molecule, carbon monoxide or CO. This gas is even more volatile. It boils at even lower temperatures. To find a comet so rich in it still holding onto it after a journey of millions of years confirms its birthplace was in a deep freeze we can barely comprehend. This chemical 1-2 punch of carbon dioxide and carbon monoxide, with water being a minor ingredient, was the first alien part of the signature. It told us I was not born where you were, but the final ingredient was the true mystery, metallic dust. The green glow was part of this. The dust itself was strange. Our comet dust is rocky. This dust was metallic. The fingerprint analysis showed traces of what shouldn't have been there. Specifically, the barcode showed the possible presence of nickel. Nickel is not a light, simple element. Nickel is a metal. It is forged in the fiery heart of a supernova, a giant exploding star. To find traces of nickel in the dust of a comet suggests a very, very different origin story. It implies that its home system was born from the ashes of a nearby supernova, or it implies that the metallicity of its star system, the amount of heavy elements available, is fundamentally different from ours. This is the alien recipe, the formula from another world. Think of it this way. Our comets are dirty snowballs made of water ice and rocky dust. Atlas was a dirty, dry ice ball made of carbon dioxide ice, carbon monoxide and metallic dust. This isn't just a minor difference. It is a fundamental rewriting of how a comet can be built. This is not a recipe that could have come from our solar system. It is physically impossible. The chemistry is wrong. The ingredients are wrong. That green light then was not just a light. It was the aroma of this alien chemistry. It was the glow of exotic ingredients reacting with our sun's light. It was the fingerprint of carbon dioxide, carbon monoxide, and nickel dust all being heated and excited, screaming their identity across millions of miles. It was the chemical signature of another star delivered to our doorstep. It was the proof that the universe doesn't just build things one way. Our sun cooks its comets using its ingredients, but that other sun, the parent star of Atlas, used a completely different set of ingredients baked at a completely different temperature. The result was Atlas, a messenger glowing green not with magic but with a chemistry that forced us to realize that our recipe for the cosmos was missing a few pages. This is not a story of a single person, it's a story of a system of patience and of mathematics. The journey of this traveller for us did not begin when it was launched from its home star. It began on a warm summer night, July 1st, 25. It began not with a bang, but with a handful of faint digital pixels. On Earth, a network of robotic telescopes quietly scans the sky night after night. They are part of a program called ATLAS, the Asteroid Terrestrial Impact Last Alert System. Their job is not to find messengers from other stars. Their job is to find rocks from our own solar system asteroids that might be on a collision course with Earth. They are our planetary guardians, our silent watchmen. On this particular night, the telescopes in Hawaii and South Africa dutifully scanned their assigned patches of sky, taking pictures, moving and taking more pictures. A sophisticated computer program then analyzes these images, looking for one simple thing, a dot that moves. Most dots, stars and galaxies are fixed, but planets, asteroids and comets move against that fixed background. The system found one, a new dot. It was incredibly faint, just a whisper of light, blurred and unimpressive. To the automated system, it was just another transient object. It was given a temporary designation and the data was uploaded to a global database shared with astronomers everywhere. At this point, it was one of hundreds of such discoveries made every week. It was boring, it was routine. No one popped champagne, no one called the news. It was just a smudge of light logged and filed. But the process of science is to follow up. Other telescopes, bigger and more powerful, were pointed at this new smudge. Astronomers, both professional and amateur, began to track it. They needed to collect more data points, more dots to connect. The first few observations are never enough. You need to see where it is tonight, where it is tomorrow, and where it is next week. Only by connecting these dots can you draw the line of its journey. As the days turned into a week and the week into two, the new data trickled in. Astronomers fed these positions into computers. The computers did what they do best. They tried to find a pattern. They tried to calculate the object's orbit. This is where the story changes. This is the holy moment. When computers calculate an orbit, they are trying to fit the object's path into a shape. In our solar system, everything travels in a closed loop called an ellipse. Your car on a racetrack is on an ellipse. The Earth going around the Sun is on an ellipse, a nearly perfect circle. Halley's Comet travels on a very stretched out or eccentric ellipse. But the key is it is a closed loop. It always eventually comes back. The computers tried to fit this new object onto an ellipse. The numbers wouldn't work. The data fought back. The program couldn't make the loop close. So the astronomers tried another shape. What if it was just barely escaping the solar system? That would be a shape called a parabola. This happens sometimes when a comet from our own Oort cloud gets nudged by Jupiter, getting a gravitational kick, just strong enough to fling it out into the deep. The numbers were still not right. Then they let the computer find the best fit with no assumptions. The number that came back stunned them. The computer spat out a value, a measure of the orbit's shape that was not 0, not 0.5, not even 1. The number was high. It was definitively, mathematically, unquestionably greater than 1. This meant the object was not on an ellipse, it was not on a parabola, it was on a hyperbola. Let's understand what that means because it is the most important part of this discovery. An ellipse, the path of the planets, is a closed curve. If you start at one point, you will always return to that point. A hyperbola is an open curve. It is a path that never closes. It comes from one direction, makes a single sharp turn, and then leaves in a different direction forever. The meaning of that number was immediate and profound. An object on a hyperbolic path is not bound by the sun's gravity. It is too fast, it is moving with too much energy to ever be captured. It is a traveller, a visitor, a tourist. The sun's immense gravity could bend its path, pulling it into a sharp U-turn, but it would not be able to hold on to it. This object did not come from here. It was not born in our solar system. It is not part of our family. It did not come from our Kuiper belt, the ring of icy bodies beyond Neptune. It did not come from our Oort cloud, the great distant sphere of comets that surrounds us. It came from somewhere else. It came from the dark, cold, unimaginable emptiness between the stars. This visitor, our green messenger, was truly interstellar. This realization changed everything. The object was no longer a boring smudge of light. It was perhaps the most important object to ever enter our solar system. It was a piece of another world, another star system, delivered to our doorstep. It was a message in a bottle thrown into the cosmic ocean, and it had by sheer chance washed up on our shore. It would make its turn around our sun, and then following the unbreakable laws of physics, it would leave. It would continue its journey back out into the deep, and it would never return. This was our one and only chance. Immediately every telescope that could be pointed was pointed. The Hubble Space Telescope, the James Webb Space Telescope, the giant observatories on the mountains of Chile and Hawaii, they all turned their attention to this guest. They had to learn everything they could, and they had to do it fast. The first thing they noticed was its most obvious feature, that beautiful ghostly green fog we spoke of. This cloud, this coma, was enormous. As the object fell closer to the sun, its ices began to heat up. This wasn't water ice like you put in a drink. This was exotic ice, frozen nitrogen, carbon monoxide, and other materials. They were turning directly from a solid into a gas, a process called sublimation. This gas, excited by the sun's radiation, was glowing that signature green. This gaseous fog was bigger than the planet Jupiter. It was a truly massive ethereal cloud streaming out behind the object to form a tail that stretched for millions of miles. But this led to a new question. We were looking at the fog, but where was the object? Where was the solid part, the thing itself? That massive green cloud was a deception. It was a beautiful shimmering veil, but it was hiding the source. Hidden deep inside that gigantic glowing fog was the true traveller, the nucleus. Astronomers had to use their most clever techniques to see it. They used radar bouncing radio waves off of it. They used powerful infrared telescopes to pierce through the dust and gas. They watched as the object passed in front of distant stars, measuring exactly how long the star's light was blocked. And when they finally put all the data together, they found it. The source of all this light, the heart of this cosmic messenger, was tiny. Not tiny like a pebble, but tiny compared to the cloud it was creating. The calculations showed a solid nucleus, a single object made of rock and exotic ice that was only about 5.6 kilometers wide. That is about 3.5 miles. Think about that. The entire object could fit inside the ring road of a small city. You could walk across it in about an hour. This small, city-sized piece of debris had travelled from another star. It had likely spent millions, perhaps hundreds of millions of years drifting silently through the interstellar void. Cold, dark, and alone. It had survived its journey, found our tiny solar system by chance, and upon approaching our sun had woken up. It had burst into this spectacular giant green display announcing its presence. It went from a faint, boring dot in a robotic telescope's computer to the most profound visitor in human history. A city-sized block of ice telling us for the first time what other solar systems are made of, and its message was just beginning to be deciphered. We have grown comfortable with the clockwork of the heavens. We look up and see patterns, rhythm, and predictability. We can predict the exact second an eclipse will begin. We know the orbits of the planets with such precision that we can land tiny machines on them years after they leave Earth. We expect the universe to follow the rules, to be orderly and to make sense. But this traveller, this messenger from the deep dark, it does not seem to care for our rules. It refuses to behave. Its journey inward toward the warmth of our sun should have been a simple story. As an icy body gets closer to a star, it should warm up. As it warms, its ice should turn to gas, creating a larger and larger fuzzy cloud or coma. It should get brighter and brighter and brighter in a smooth, predictable curve as it gets closer and hotter. We know this story. We have seen it many times with comets from our own solar system. This object, however, is different. It is defiant. When we watch it, it does not follow that smooth, steady curve. Its light is not a gentle, consistent glow. It is a wild, stuttering pulse. For days, even weeks, it might remain a faint, disappointing smudge in our telescopes, barely visible. We might think its journey is over, that its ancient icy heart is finally spent. And then, without any warning at all, it flares. In a matter of hours, or perhaps even minutes, its brightness will suddenly explode. It can become 10, 50, or even 100 times brighter than it was the day before. It blooms in the darkness, throwing off a brilliant cloud of gas and dust that catches the sunlight, announcing its presence like a shout in a quiet library. It is a stunning, violent, and utterly unpredictable display. And then, just as quickly as it began, the show ends. The light fades. The brilliant cloud of gas and dust dissipates into space, and the object shrinks back into the gloom as if exhausted by its own outburst. It becomes quiet again, leaving us to wonder when or even if it will flare up again. This is not the behaviour of a simple, predictable ball of ice. This is the behaviour of something complex, something chaotic. This is the rhythm of a wild heart. So what is happening? Why this chaotic rhythm? The first clue lies not in the object as a whole, but on its skin. We must stop imagining it as a perfect, smooth sphere of ice. That is not what it is. This is an ancient object, a survivor of an unknown history. It has travelled for millions, perhaps billions of years through the cold interstellar dark. Over those long ages, a crust has likely formed on its surface. This crust is not a simple uniform layer. It is a complex, tortured and uneven landscape. Think of a frozen river in the deep of winter. Some parts are thick, solid ice. Other parts are thin and brittle with patches of slush and snow. This object's crust is like that, but on a cosmic scale. It is a patchwork of different materials. Some areas might be dense, dark rock and dust baked hard over eons by cosmic rays. Other areas might be thin, fragile sheets of frozen gases, like nitrogen or methane, covering deep pockets of even more volatile ices trapped just below. This crust is a poor conductor of heat. It acts like a thick, ragged blanket protecting the deep interior from the faint warmth of distant stars. For millennia, the object's core has been in a deep, deep freeze. Now, after an eternity in the cold, we introduce our sun. This object is finally approaching a source of real heat. The sunlight, even though it is still weak out past the orbit of Mars, begins to warm that uneven crust. The heat does not warm the object evenly. It is like holding a match to a large frozen block of mud and ice. Nothing happens for a long time, until the flame finds a weak spot. The sunlight probes the surface looking for a flaw. It finds a thin patch, a crack, a spot where the ice is different. The heat penetrates this weak point and reaches the volatile ices buried just beneath the surface ices like carbon monoxide or carbon dioxide, which can turn from a solid straight into a gas at incredibly low temperatures. When this happens, the pressure is immense. A small amount of solid ice explodes into a massive cloud of gas. This gas is trapped beneath the brittle crust. The pressure builds and builds and builds until the crust can no longer contain it. With a violent rupture, the surface fractures. A high-pressure jet of gas ice and dust bursts out into the vacuum of space. This is not a gentle plume, it is a focused, powerful explosion, a natural rocket engine firing. This single jet catching the sunlight is the flare we see from Earth. It is a cryovolcano, an icy geyser erupting from a body that has been quiet for longer than all of human history. Because the crust is a random patchwork of weak and strong spots, these explosions are completely random. We have no way of knowing where the next week's pause is, or when the pressure will become too great. The object is quite literally cracking up as it gets closer to our star. This uneven surface explains the what and where of the flares, but there is another layer of chaos that explains the when its motion. This object is not spinning in a polite, orderly way. Think of the Earth. It spins on its axis once every 24 hours, a stable, predictable rotation. This gives us our familiar cycle of day and night. Most objects in our solar system spin in a similar stable way, but this visitor, it is not spinning, it is tumbling. Imagine throwing a baseball with a perfect as height spiral. That is a stable rotation. Now imagine taking a lumpy potato or a brick and just tossing it end over end. It flips and rolls and wobbles chaotically with no pattern at all. That is what this object is doing. It is tumbling through space. This chaotic tumble has a profound effect on its heating. A stable spinning object gets heated somewhat evenly, like a chicken roasting on a rotisserie. A tumbling object does not. For a long period, it might keep one side, perhaps a thick, rocky and stable side, facing the sun. During this time, it absorbs heat, but no jets are released. It stays dim. Then, in its chaotic tumble, it suddenly flips. It exposes a brand new, deeply frozen and fragile side to the full force of the sunlight. This new side, which was protected just moments before, is suddenly hit with a blast of warmth. The ice beneath its thin crust instantly flashes to gas, the pressure builds, the crust cracks, and whoosh, another violent jet erupts. This combination, an uneven fractured surface and a chaotic tumbling motion, is the perfect recipe for unpredictability. It is a system designed for chaos. We cannot predict when it will tumble, nor can we predict what part of its surface will face the sun when it does. We are not watching a simple rock, we are watching a complex machine designed by nature to surprise us. This is why we cannot see it as just a simple dead ball of ice. It is a complex, dynamic entity. It has a personality shaped by its violent and unknown past, and it is reacting to the sun's warmth in its own unique, defiant way. It is not a passive victim of the sun's gravity just falling past us. It is an active participant in its own journey. It is talking back to the star, shouting with its sudden flares of light. This wildness is a gift. It tells us that this object is not sterile or dead. It is a place of geology, of pressure, and of change. It is telling us in the only language it knows the story of its long cold journey and its sudden violent awakening. This object, this visitor from an unknown star system, did more than just fly through our cosmic neighborhood. It forced us to confront one of the biggest questions we have. When we find something truly strange, what is it? This isn't a loud, angry argument. It is a quiet, profound, and deeply important debate. It is a philosophical discussion happening in the language of physics and astronomy. The data we collected was incomplete and puzzling, and in that uncertainty, three main schools of thought emerged. Each represents a different way of thinking, not just about this one object, but about our place in the universe. The first and most common viewpoint is the cautious one. This is the baseline of good science. This perspective states that the visitor was almost certainly a natural object. Yes, it was strange. It was perhaps the strangest comet-like object we have ever seen. But the universe is a place of infinite variety. We have explored only a tiny fraction of our own solar system. We are still surprised by the moons of Jupiter and the geology of Pluto. We have directly studied only a handful of comets and asteroids. To assume that our tiny sample represents every possible type of object in the entire galaxy is simply not logical. This cautious view argues that just because this object didn't match our models doesn't mean the models are wrong, it just means our experience is limited. Perhaps in its home system the frost line is different, and objects are formed from frozen nitrogen or solid hydrogen, not water ice. This could explain why it accelerated this ice, turned to gas and pushed it, but in a way that was invisible to our telescopes, creating no visible tail. Perhaps it was a contact binary, two smaller objects that were gently stuck together. As it got closer to our sun, the sun's gravity pulled on it unevenly, causing it to spin faster and faster until it simply broke apart. This would explain the fragmentation. This viewpoint is built on a famous principle called Occam's razor. The simplest explanation is usually the right one. And what is simpler? That an object from another star system is a type of comet we have never seen before, or that it is a piece of advanced functioning or derelict alien technology. For most scientists, the weird comet hypothesis, while not perfect, is by far the most likely. It doesn't require us to invent new physics or discover intelligent life. It just requires us to accept that the universe is more complex and varied than we currently know. Then we have the bold viewpoint. This is the one that captures headlines and is most famously associated with a physicist like Avi Loeb. This viewpoint doesn't necessarily claim it was aliens. Instead, it asks a more philosophical question. When is an object so strange that we must begin to seriously consider possibilities other than nature? This perspective is a challenge to the conservative nature of science. It argues that if we always default to the "it must be natural" explanation, we might be blinding ourselves. If a tribe of isolated jungle dwellers found a stainless steel smartphone, they would have no framework to understand it. They might conclude it is a strange shiny rock, or perhaps a gift from a sky god. They would try to explain it using only the natural world they know. They would be wrong. The bold view argues that we humanity might be those jungle dwellers. We are looking at an object that had multiple profound anomalies. It didn't have a tail like a comet. It accelerated away from the sun as if it were being pushed, but with no visible engine or gas. It was shaped according to some data in a way that was long and perhaps flat, and then broke apart. From this perspective, you have to ask how many 1 in a million natural explanations do you need to stack on top of each other before a single 1 in a billion artificial explanation starts to look plausible. If it were technology, the data would make a different kind of sense. The acceleration could be from a light sail, a very thin, large, lightweight sheet designed to be pushed by starlight itself. Such a thin structure would also be fragile, explaining why it broke apart when it got too close to our sun. This viewpoint is a check against our own assumptions. It is a warning against scientific arrogance. Its supporters argue that in the search for extraterrestrial intelligence, we shouldn't just be listening for radio signals. We should also be looking for messages in a bottle, physical artifacts, probes, or even debris passing through our system. To immediately dismiss the possibility they say is not good science, it is a failure of imagination. A failure of imagination. Finally, there is a third path. This is the middle way, and in many respects it is the most fascinating and romantic of the three. This path suggests the object was natural, but not in the way we first think. It wasn't just a comet. It was something far more profound, a piece of a story. This idea suggests that the visitor was a fragment of a much larger object. Two main possibilities exist here. The first is that it was a planetesimal. This is a baby planet, a building block of a solar system that never finished forming. In the chaotic early days of its home system, perhaps as giant planets were moving around, this planetary embryo was ejected and flung into the lonely darkness of interstellar space. It is a seed of a world that never was. The second possibility is even more dramatic. The object could have been a piece of a dead world. Imagine a planet in another solar system, one that was similar to Earth or Mars. It developed a crust, a mantle, and a core. Then billions of years ago, it was struck by another massive object in a cataclysmic, planet-shattering collision. This impact, far more violent than the one that created our own moon, would have blown the planet to pieces. Most of that debris would stay in its own system, but some fragments blasted with enough force would escape their star's gravity forever. Our visitor could have been one of those fragments. It could have been a piece of an alien planet's rocky crust or even its iron-rich mantle. This middle way explains the data beautifully. If it was a piece of rock or metal from a planet's interior, it would obviously have no water ice and would not create a comet's tail. And if it was a fragment from a violent explosion, it would already be full of internal cracks and stresses. As it passed our sun, the sudden heating and gravitational stress would be more than enough to make it crumble along those ancient billion-year-old fault lines. This explanation is in its own way as profound as the bold one. It suggests that the space between the stars is not empty. It is haunted by the debris of creation. It means that for a brief time we flew a probe past a piece of another solar system's planetary core. We were in effect performing an autopsy on a dead world from light years away. These three paths, the weird comet, the alien technology, and the fragment of a lost world, define the legacy of this mysterious visitor. Whatever it truly was, its journey through our system held up a mirror to ourselves. It forced us to debate the very nature of evidence, the limits of our knowledge, and the courage it takes to ask the biggest questions of all. The data is astonishing. The speeds are hard to comprehend. The chemical fingerprints read from faint reflected sunlight are a checklist of interesting compounds. But in the end, after all the numbers are crunched and the graphs are plotted, we are left with a simple human question: what does it mean? Why do we tiny creatures on a small blue planet care so much about a frozen rock from a star system we will never see? The answer is that we are not just creatures of logic. We are creatures of story. We are driven by a need to understand our own place in the cosmos. An object like 3I Atlas is not just a scientific curiosity. It is a potential clue to the greatest mystery of all. Are we alone? And how did the story of life on Earth even begin? This is where the cold, hard data of astrophysics crosses over into the realm of philosophy. The journey of 3I Atlas forces us to consider one of the most profound and tantalizing ideas ever proposed, an idea that blurs the line between science fiction and scientific possibility. This is the concept of panspermia. It sounds like a complicated word, but the idea behind it is beautifully simple. Pan is a Greek word meaning all, and spermia means seed. The seeds of life are everywhere. This theory suggests that life, or at least the fundamental building blocks of it, is not a unique event that happened only on Earth. Instead, it proposes that these seeds are scattered throughout the universe, drifting through the vast, empty darkness of interstellar space. These seeds, in the form of organic molecules, or perhaps even hardy microorganisms, travel on ships, and these ships are comets and asteroids just like 3I Atlas. Think of the galaxy as a vast cosmic garden. Stars are born and planets form around them. On some of these planets, life may take root. Then through violent events like asteroid impacts or gravitational tugs of war, material from that living system is ejected, flung out into the void. These fragments, frozen and protected, then travel for millions or billions of years. Most drift into the darkness forever, but some purely by chance will one day enter another solar system and crash onto a new fertile planet. They deliver their cargo, seeding that new world. This is where 3I Atlas becomes so important. We know from our observations that it wasn't just a dry, inert piece of rock. It was a dirty snowball of cosmic proportions. Its composition hinted at as it broke apart was a treasure trove of the very ingredients life needs. It was packed with water ice. Not just a little, but a huge amount. This is the solvent of life, the liquid, where all the crucial chemical reactions take place. It was rich in carbon. Carbon is the backbone of all life as we know it. It is a master builder atom able to link with itself and other elements to form the long, complex chains that make up proteins, DNA, and cell membranes. Most important of all, it was likely filled with organics. When scientists say organic, they don't necessarily mean living, they mean complex molecules built around carbon. These are the pre-assembled parts of life. They are the amino acids that build proteins, the fatty acids that build cells, and the sugars that provide energy. 3I Atlas, in essence, was a delivery package from another star, and its contents were all the ingredients for a life starter kit. It wasn't delivering life itself, but it was delivering the potential for life. It was carrying the raw materials cooked in the heart of another solar system and shipped across the galaxy, ready to be dropped into a primordial soup on a young planet just like Earth was 4 billion years ago. This idea has profound implications for how we see ourselves. For centuries, we have struggled with the miracle of our own existence. How did non-living chemicals, carbon, hydrogen, oxygen, suddenly assemble themselves into the first living cell? The odds seem mathematically impossible, like a tornado blowing through a junkyard and accidentally assembling a perfect functioning airplane. We have always assumed it was a local miracle. We believed that Earth was a uniquely special, incredibly lucky place where this impossible event just happened to occur. This would make us a complete cosmic accident, a rare and beautiful exception in a universe that is otherwise dead empty and sterile. But panspermia, supported by the evidence of travellers like Atlas offers, was a completely different story. It suggests that life is not a local miracle but a galactic exchange. The universe it turns in is a giant cosmic kitchen. It is constantly mixing and sharing ingredients. Star systems are not isolated islands. They are connected by a vast invisible highway of these comets and asteroids. If the building blocks of life are being constantly delivered to every new planet in the galaxy, then the problem of life's origin changes. The incredible luck is not needed. The impossible odds are gone. Life is no longer a miracle, it becomes an inevitability. If you supply the raw ingredients to every corner of the cosmos, then life will likely pop up wherever the conditions are right, where there is liquid water, a stable source of energy, and enough time. This means that life on Earth may not be from Earth at all. Its deepest chemical ancestors may have formed in the atmosphere of a gas giant in another solar system, or in a warm, watery ocean on a planet orbiting a long-dead star. We are, in the most literal sense, the children of the stars. We are connected not just by the atoms of heavy elements forged in supernovae, but potentially by a shared galactic biology, an exchange of organic material that has been going on for billions of years. We are not an isolated we are part of a vast cosmic us. This all might sound like beautiful speculation, but it's supported by the final stunning fact. Before the year 2017, the number of interstellar objects we had ever confirmed was 0. For all of human history, we had never seen one. Now, in just a few short years, we have definitively identified 3 Oumuamua Borisov and 3I Atlas. We have gone from 0 to 3 in the blink of an eye. This is not a small discovery. It is a revelation. It's like a person who has lived their whole life by a river wondering if any fish were in it. Then one day they invent a fishing net. They throw it in, and in 5 minutes they pull out 3 large fish. What does this tell them? It tells them that the river is not empty. The river is full of fish. For billions of years, these interstellar travellers have been streaming through our solar system completely unseen. They have been hitting Jupiter, Saturn, and yes, even the early Earth, delivering their cargo of water and carbon. We were just blind to them. Our telescopes were not good enough. We have only just now, in our own century, built the nets, the powerful wide-field sky surveys like pan-stars that are capable of catching them as they fly past. The fact that we found 3 so quickly with our still limited technology implies a staggering truth: the sky is full of them. The space between the stars is not an empty void, it is a bustling highway. There are likely millions, perhaps billions of these objects passing through our solar system right now unseen. We are not an isolated island. We are a harbour on a vast cosmic ocean, and the ships are arriving all the time. We are just for the very first time in human history learning how to see them. And with new observatories coming online, we are about to see many, many more. The trickle of data will become a flood, and with it our understanding of our own cosmic connection will change forever. And so we arrive at the end of our journey, at least our journey with this particular silent visitor. We have followed its path, we have marvelled at its origins, and we have speculated on the profound questions it has asked of us. But like all great journeys, this one too must find its conclusion. We must now face the simple and unavoidable truth: Atlas is leaving. Its story in our skies is coming to a close. Right now it is moving at an incredible speed, many thousands of kilometers per hour, flung away from our sun by the very gravity that briefly welcomed it. It is already faint, a subtle smudge in our most powerful telescopes. Soon it will be just a point of light, and then nothing. It will vanish dimmer and dimmer, until it is reclaimed by the profound eternal darkness it travelled through for so long. It is returning to the deep interstellar night, the vast cold and silent space between the stars. Its journey is a one-way trip. Unlike a planet in our own solar system bound by the sun's rhythm, Atlas will not return. It will not swing back around in 1,000 years or 1,000,000. It is passing through a traveller on a trajectory that will carry it out of our reach forever. This isn't a see you later, this is farewell. But we should not see this as an ending defined by loss. We should see it as the closing of a remarkable chapter, because Atlas was never just a comet. It was and is a moment. It was an event that shifted our perspective. For a brief shining period, it captured our collective imagination and forced us to look up beyond our own celestial neighbourhood. Its passage was a profound demonstration of a new and vital truth: the galaxy is not a static collection of isolated, separate systems. It is a living, breathing and dynamic network. It is a place that is unceasingly exchanging material. Atlas was the proof. This object born in the disk of gas and dust surrounding a completely different star, perhaps billions of years ago, and many light years away, crossed the unimaginable gulf to visit us. Think about what that truly means. The galaxy is a vast cosmic ocean. We used to believe we lived on a perfectly isolated island, that our solar system was a closed box. But visitors like Atlas and Oumuamua before it are like messages in a bottle washed up on our shore. They prove that there are other shores. They prove that the ocean itself is moving, that currents and tides are carrying pieces of one star system to another. The galaxy is breathing. The stuff of one star's family is constantly being shared with another. We are all participants in this grand galactic exchange, whether we realise it or not. And that brings us to its legacy. What does this visitor leave behind other than a trail of scientific papers and fading photographs? It leaves us with a challenge. It leaves us with an urgent call to action. The legacy of Atlas is that it urges us to be ready. We were caught by surprise. We were lucky to see it at all. We scrambled, pointing every telescope we could at it as it flew by. We were passive observers standing on our shoreline watching the magnificent ship sail past. But what if we could have done more? What if the next time we are ready? This is the great new idea it has inspired the need for rapid response missions. We can no longer be content to just wait for these visitors. We must be prepared to intercept them. Imagine this, a high-speed probe perhaps using an advanced solar sail parked in a special stable point in space just waiting. It would be a sentinel, a cosmic go-bear ready to be launched at a moment's notice. The next time our surveys pick up a faint dot moving in a way that tells us it comes from another star, we will be ready. We won't just watch it, we will chase it. We will launch our probe, match its incredible speed and fly alongside it. We could sample the dust from its tail. We could take high-resolution images of its surface. We could discover definitively what it is made of, where it came from, and what stories it carries from its home star. This is no longer science fiction. It is the necessary, exciting next step in our exploration of the cosmos. Atlas has thrown down the gauntlet, and now it is our turn to respond. As we end our time together tonight, and as Atlas itself fades back into the quiet, let's hold on to that final contemplative thought. This visitor was a profound reminder of two essential truths: connection and humility. It reminded us of connection. We are not separate from the universe. The atoms in our bodies, the very iron in our blood, were forged in the hearts of stars long dead. And here was Atlas, a piece of another distant star system made of that very same star stuff. It was a cousin visiting from across the galaxy, reminding us that we share a common cosmic heritage. And finally it reminded us of humility. We are not the center of the universe. We are not the only or even the most important story. We are a small, quiet harbour in a vast, busy and ancient ocean. We are a single fleeting thought in a galactic mind. Atlas reminds us that we are not alone, not in the sense of other civilizations perhaps, but in the sense that we are part of a grand, interconnected and ongoing story that is so much larger than ourselves. So as you drift off to sleep, let the image of Atlas be a peaceful one. Do not think of its departure as a lonely one. See it instead as a brave traveller, its duty done now gliding silently back into the great dark river of the cosmos. Its journey and our observation of it is a beautiful, complete thought. It is a whisper from the galaxy, a reminder that we are part of an unimaginably large and wonderful whole. And we are lucky, so lucky to have been here to witness it. Good night.